We're going to do a short and fast video, short and sweet, on the law of conservation of mass. I know this law of conservation of mass sounds so confusing because it's like, it's a law, okay, what's a law? And conservation and of mass. So there's a bunch of terms that doesn't make sense. But in reality, law of conservation of mass, the concept is actually pretty simple. Basically, it's stating that matter or your atoms or anything that's sort of mixed together, if things are formed or if things are broken apart, it doesn't matter what the result is. The mass from your reactants, what you start off with, is going to be exactly the same as what you ended up with. So an example that I use in class is really a simple one, such as your baking soda and vinegar. So let's, for example, if we have 20 grams of baking soda and we react this with about a liter of vinegar. You know the reaction between vinegar and baking soda is that you get a lot of bubbles. What basically is generating is a lot of carbon dioxide. But if we're to collect all of the gas that's sort of created, and also whatever is left, like the liquid remaining vinegar of the remaining undissolved baking soda, and if we weigh all that, that mass is going to be the same as what you started off with. That's what the law of conservation of mass is. So basically what you started off is going to be the same as what you ended up with in the mass. And you can understand that chemicals can change forms, change shapes, and all that. So even though it looks slightly different, the mass is essentially the same. So another example of this is like rusting of nails. So rusting, you have your iron, and it reacts with the oxygen in the air and gives you your iron oxide. And how this is that if you actually take the amount of iron that you have and you take the amount of oxygen that's being absorbed and changed into rust, the mass of your rust is going to be the same amount of your oxygen and your iron added up together. It's not going to change. Why this is important is that so then this actually tells us that matter, all of our atoms and all that stuff, is not created from nowhere. It sort of just changes forms, changes into a different way, even though it looks different, but the mass is essentially the same. So there's a deeper debate about this, but that's what law of conservation of mass is. It's a very important law because even though it's very simple and sort of complicated at the same time, but it's a very important law about how our universe sort of either started or how matters take place. So the important part of this law of conservation of mass is that we have to sort of lead into balancing equations, and you can see that this is your reactants and this is your products. And why we have to balance it is because the mass is going to be the same. So here are my coefficients, basically saying how many of each that I need. So for iron, basically in this ratio is saying that, let me get my pen here, you need 4 iron atoms, and for every 4 iron atoms you're going to combine that with 3 O2. So this is 1 O2, this is 1 O2, and this is 1 O2. So basically it combines in this ratio. So every time you have this set of 4, this set of 3, you're going to get a bunch of your iron 2O3, and you will get 2 of them. That's the ratio to form the rust. So basically that's the reason why we balance equations, is that we have to keep all the masses essentially exactly the same, because it has to agree with the law of conservation of mass. So hopefully this short video gives you an idea of what law of conservation of mass is, and it leads into sort of balancing your reactions, because that's essentially the reason why we need to balance our reactions. Okay, so I'll see you in the next video.